Okay. Oops. Yes, hello, my name is Heribert Vallant. I work for JOANNEUM Research, which is a research organization here in Austria, and we are doing mainly applied research projects. The company is owned by the public, and we have 3 owners, the local government of Styria, Carinthia, and Burgenland. Therefore, JOANNEUM Research plays a key role in facilitating the transfer of technology and knowledge to these regions. JOANNEUM Research has 7 research units, and I am from the Institute Digital, the Institute for Information and Communication Technologies. At the competence group on cybersecurity and defense, our research topics are cybersecurity modeling, formal verification, and AI-based detection of cyber attacks. Within the RESOLVE project, JOANNEUM Research is responsible for cybersecurity. The ongoing transformation of the electrical energy system from the classical generation consumption schema to the fully digitized, bidirectional, decentralized energy system with different players having different roles involves technical and organizational issues, but also security and privacy issues. New intelligent distribution algorithms in a smart grid and the proliferation of the Internet protocol makes the control devices vulnerable by a broad range of security issues known from the ID networks. The Ukraine, for example, was struck by a large cyber attack on the power distribution network, causing a complete blackout event. This blackout affected approximately 200,000 customers. The attack scenario was the following, which is also very common for industrial control systems. There was a phishing email which comprised Microsoft Office document. Then via this, they got the credential of a user in the business network, and then they performed a lateral movement between the machines, and then they found a machine which has a VPN tunnel to the OT network, and then they were in the OT network, and then they uploaded there some firmware to the communication devices, and then they performed the SCADA hijacking. They also deleted master records and log files, so they obfuscated their attack. Designing security into cyber-physical systems from the beginning on is the most cost-effective way, since it minimizes risk and financial expenses. Our approach in RESOLVE is aligned to Microsoft Trustworthy Computing Security Development Lifecycle. This is a software development process used and proposed by Microsoft to reduce maintenance costs and to increase the reliability of the software with regard to security-related issues. This is based on a classical spiral model. You have several phases: requirements, design, implementation, verification, also deployment, support, service, operation. As RESOLVE is the research and innovation action, the focus was on the first 4 phases. Let's have a closer look to the RESOLVE approach. The starting point was the data flow diagram of the RESOLVE system architecture, which in turn was based on the results of the SCAM interoperability modeling. Based on a proposal of security measures for smart grids from ENISA, the European Agency for Network and Information Security, and also some risks from the Austrian national funded project called Risk Analysis for Information Systems of the Electricity Industry, a list of applicable threats was identified. The next step was the risk assessment of the individual components of RESOLVE. You have already heard this is power electronic device, power measurement unit, power quality monitor, and therefore each partner assesses the risk of their technology they are in charge of. This was then used for the threat modeling process. For this we used also a Microsoft tool, the Microsoft Threat Modeling tool, which on the one hand already have the template that provides corresponding security parameters for processes, devices, data communication channels, widely used in the IT domain. But since RESOLVE we use different protocols and components from the energy domain. We have to analyze these protocols and assets again and to specify the security parameters for these components and put it into the template. The outcome of this was a list of potential threats, and we finally got more than 2,000 identified cybersecurity issues within Resolved. Now, if we have our threats, the requirement for sure is to mitigate these issues. So this was the requirement section. Now let's move on to the design step. Security building blocks are measures that can be applied to devices, application protocols, communication channels in order to function in a secure way and to mitigate these identified threats. A security building blocks, for example, could be some communication line security, where you specify that you want to segregate your network. There are several possibilities. One could be a physical segregation or a logical segregation. Other building blocks could be also encryption. Well, we have now set the different security building blocks, but not all of them might be applicable because each component may have some specific constraints. These constraints, for example, might be bandwidth, computer power, memory, or the protocols itself. So for each individual component of the resolved system, these constraints were captured and analyzed. The review of the constraints has shown that the computing-intensive operations like state-of-the-art encryption algorithms can be enabled by the components within Resolved. That's very important. Based on that individual analysis, the secure implementation guidelines for Resolved were outlined and applied. Finally, to check the security measures has to be performed. We do this by a threat list focused approach, which offers a very effective way to perform the initial security checks. For the test itself, we use different tools, and of course, experienced specialists are needed. I want to mention that cybersecurity is an ongoing process. It is not possible to 100% secure such a complex system. There's always a residual risk that has to be handled. Drivers for these risks at the energy domain are IT, OT, convergence, cross-sector coupling, new participants with different goals like aggregators, prosumers, local energy communities. Also, if you introduce industrial IoT devices, this opens also new threats to the system. News and regulation and business models which have to be addressed at the energy area are also drivers for these risks. And of course, there are different types of attackers: hacktivism, organized crime, cyber terror, up to state-sponsored attacks. So what can we offer to you? This risk-based threat modeling approach, followed by these pen testing skills, can be applied to other domains. In fact, the threat modeling approach we have also applied to smart production, autonomous driving, or water supply, where we modeled the security features of the assets used there. From the research perspective, there is a highly ranked topic in the security research domain, which is called formal verification. The meaning of that is how to prove formally that something is secure. And by integrating such a formal verification step, our semi-formal threat modeling approach can be brought up to the next level. Well, that's all from my side about the cybersecurity topic.
Thank you, Heribert. And I think it was very interesting for everyone to see.
Hello? Hello?
Yeah, sorry, I got muted. Yes, so thank you very much, Heribert, and we will, without wasting any time, go into the question and answer session. Maybe Santi, I could start with you. You probably know better about the implications of cybersecurity on the distribution grid. So would you like to ask any questions to Heribert on that?
Yes, thank you, Heribert. Nice to meet you again. This is one. Hi, now it's unmuted.
Okay.
Oh, sorry. Hi, so Herbert, nice to meet you again. Cybersecurity is this one of these things that you have more fear than security when talking about. No, my question is, do you think that the distribution network is especially vulnerable? I mean, because in your slides I have seen smart homes, so Internet of Things and all this, which is the let's say no, not the normal, but the more known risk places. But when you have been investigating for this Resolve project about the distribution network, is this especially vulnerable?
Let's say it that way, that there are possibilities which could affect the distribution network. For example, here in Styria, we had once a case where a counter request from the gas net jumped over to the electricity network. And within that request, there was a parameter set, a flag, so that the meaning of the flag was to redistribute to all the other components in the network, and this was overflooding the whole system. So at the control center, they didn't see what happens outside, so they have to send out the personnel to the substation to look what happens. Everything worked fine, but at the control center, it was not possible to see what's going on. This was some kind. It was not an attack, but it was similar like a denial of service attack.
But I mean, also, do you think that the distribution sector has the right mindset for preventing hacking and all this, any kind of security, IT security risk?
Yes, for sure they have this mindset. Yes, at least here in Europe.
Yeah, and I think yeah, just connecting maybe Montse here. Maybe I see a lot of now companies trying to offer this kind of cybersecurity solutions within the electricity sector. Do you also have any questions on that for Heribert?
Honestly, I don't really have a question because I don't know like very much this topic. Everyone talks about it, no? But one question that I had maybe is in Resolve project, and in any project I imagine you work, Heribert, there's like many partners involved, everyone with their own cybersecurity story, you know, because everyone, I don't know, at least what we see from vendors is everyone says they're very cyber secure. So how do you maybe recommend or manage, no, like when you work in a project with different stakeholders, how do you kind of harmonize and make sure that there's not like a gap, no, that you can see just because of the, no, of the amount of providers involved or of stakeholders?
Within Resolve, it was very good because we could introduce this security by design process. So every partner has his new component, and we were at the beginning with them, and we could look into the components, and so also then look at the security building blocks which are needed to make them secure. So does this answer your question?
Yeah, thank you.
Okay.
Yeah, good. Thank you, Heribert, and thank you.